Okie dokie. Yep. Yet another particle physics reaction. Uh, I have a lecture where I showed my proof that I worked at Fermilab, and so I'd like to show a little bit of the proof that or a residue from my years as a particle physicist at U of A and Fermilab. So that's why you're seeing a lot of particle physics lectures. And it's just I'm trying to make life easy for particle physicists who are starting out and would like easy ways to do problems, reactions. I promise to get some more math lectures in soon. Okay, here we go. Today we're going to look at the reaction of some mass m0 plus 3m0 will form some h particle right here. We'll have the m0 go at a velocity of 0.8 c, and we'll have the 3m0 go at a velocity of 0. So let's get started with this reaction. So here's our initial reaction. We have Mr. A with a rest mass of m0 going at a velocity of 0.8 c. And we have Mr. B with a rest mass of 3m0 going at a velocity of 0. So we'll talk about the initial let's see what we have afterwards. Afterwards, we have Mr. H, and Mr. H will be moving at a velocity that we don't know, and that we want to figure out. And we'd also like to figure out the mass of the resulting particle that is made by these two particles fusing together. So the rest mass of the resultant particle we'd like to know also. Okie dokie. So, let's talk about the momentum initially. The momentum initially, total momentum initially, is Mr. A with a mass of m sub 0. Here's his velocity, 0.8 c, and then the square root of 1 minus 0.8 c divided by c squared is the relativistic momentum of Mr. A. Of course, since this has a velocity equal to 0, it will have a 0 momentum, so I did not include that in this equation. And the final momentum over here is the rest mass of Mr. H times his velocity, neither of which we know, and then the square root of 1 minus the velocity of Mr. H squared divided by c squared. This is the relativistic momentum of the H resulting particle. Alrighty. I just moved this guy over here and move this guy over here. Notice this guy, the C's will cancel, and you'll have the M0 and the C right there. And when you just figure out 0.8 divided by the square root of 1 minus 0.8 squared, you'll get 4/3 right there. So if you figure this out, you will get this. And just as a note, notice that this is the sum of the initial momentum, just as a note. Okie dokie. That will give us this equation. We talked about momentum. Let's talk about energy. Initially, the energy is going to be, of course, the relativistic energy of this particle, total energy, of course, we're talking about. So there's the relativistic total energy of particle A. Particle B does have isn't relativistic because it has a velocity of 0, so it will have a rest energy of 3m0 c squared, as per Einstein's famous equation. And the final energy of Mr. H will, of course, be the rest mass of Mr. H, c squared, divided by the square root of 1 minus the velocity of Mr. H squared divided by c squared, neither of which we know, and we're trying to figure out what they are. Okay? So, just like before, I put this guy in front right here. I just flipped the equation, put this person in front. And again, the C's will cancel here. You'll get the square root of 1 minus 0.8 squared. You'll get m0 squared 1 over the square root of this number will be about 1.67 plus 3 of these m0c squareds will give you the 4.67 m0c squared. So this algebraically becomes this, and I just flip this over here so we could see this. And just as a note, I just want to emphasize that this will be the sum of the initial energies of the reaction here, just as a note. Okay. Yeah, we're going to do something a little, we just now need to, we have two unknowns and two equations, this equation and this equation. And what we'll do is we'll multiply this one by c. So there's m0h vc. That's the top here. And we'll take this equation and divide it by this equation. So, of course, the bottoms will cancel. So notice I didn't include the bottoms here because those two are identical, so they'll cancel. So you'll have m0 v, and I told you we multiplied by c, so that's that. And then we'll divide it by this, and we'll get this right here. And so this divided by this will give you this if you multiply this by c. And of course, you'll have to multiply this by c, which you'll see in a second, because if this divided by this is this, then this divided by this is right here. And so notice I have the 4/3 m0, c has turned into a c squared because I told you I'm multiplying that by c. So that c is going to put another c over there, c squared. And we'll divide it by this right here. Alrighty. And if we cancel this and cancel that and cancel a c and cancel one c, you'll get v over c, which I algebraically did for you right here. So this becomes this. So v over c is equal to this. Well, the m0s and the c squareds will cancel. And so v over c will be 4/3 over 4.67. And if you solve for v right here, you just multiply by c. So 4/3 over 4.67 is about 0.286. And then you scoot over the c, you'll get a c right there. So now we know the velocity of the ending particle, Mr. H. This will be the velocity of Mr. H. So we know that. That was one of the things we wanted to know. And then the next thing, of course, we'll want to know is what is this rest mass? And we can solve that. The easiest probably place is to solve it for right here. m0h is equal to this, so you can cancel the c squared. So you get 4.67 m0. There's the 4.67 times m0. And you need to multiply times the square root of 1 minus v squared over c squared. So I wrote this a little bit funny, so don't get confused. You say you have to multiply. You got to swing it up. You got to multiply. Why'd you put it on the bottom? Well, I have a little sneaky -1 here because I made a, I wanted to, didn't want to rewrite this entire lecture. So, of course, this is upstairs. Because I wrote a -1, it'll be this to the power 1 upstairs. And so when you take 4.67 times the square root of 1 minus 0.286 squared, then, or if you just calculate this out right here, remember to if you type it like this, make sure to put a little to the power of -1 of this entire square root. Then I promise you this whole number will turn into 4.47 times m0. So now we have the mass of rest mass of Mr. H, which was one of the things we wanted to know. The rest mass of Mr. H is 4.47 times whatever the mass of Mr. A was, or 1/3 of the mass of Mr. B here. Alrighty. Well, I know we've done quite a bit of particle physics, but I hope it's helped you out in your career. Thank you very much for watching. I look forward to any comments at the bottom of the lecture.